Why evolution of computing is useful and important to know. Knowing the evolution of computing provides a foundation for learning, innovation, and critical thinking in an increasingly digital and technology driven world. It empowers individuals to participate actively in the digital age and make informed decisions regarding technology adoption, utilization, and impact. In the field of computing, there are various aspects which have evolved over the years, such as hardware, applications, software development practices, information processing, industrial revolutions, technological revolutions, data storage and processing, evolution of web, software development architecture, emerging technologies. In this video, we shall go one by one and see how each of these aspects have evolved. Coming to hardware, the generations in computer science is primarily associated with hardware advancements. First generation marked the advent of electronic computers. Vacuum tubes were used for processing and magnetic drums for the data storage. Examples are ENIAC and UNIVAC computers. Second generation, transistors replaced vacuum tubes, resulting in smaller, more reliable, and more efficient computers. Magnetic core memory was introduced, offering improved data storage capabilities. Examples include IBM 1401 and IBM 7090. Coming to the third generation, the integrated circuits replaced individual transistors, leading to even smaller and more powerful computers, mini computers and time-sharing operating systems. Examples are DEC PDP-11, IBM System 360. Fourth generation, microprocessors were introduced, combining the CPU and other components onto a single chip. This revolutionized the computer industry, leading to the development of the personal computers and the rise of software industry, like Apple II, IBM PC. And last one, the fifth generation from 1980s till present, characterized by the development of advanced parallel processing, development of intelligent machines capable of learning and problem solving, supercomputers, neural networks, robotics. So this is all about the hardware evolution.
Applications. The concept of generations for the type and complexity of the applications can refer to different stages of eras. The first generation of technology and applications typically refers to early computers such as ENIAC, vacuum tube based electronics, basic applications like simple calculation programs. Mainframe and mini computer generation comes next, comprised of large centralized computers used by large organizations for data processing, while mini computers were smaller and more affordable versions that found use in smaller businesses. Like the applications like the batch processing, payroll systems, early forms of business software comprised of this generation. Personal computer, the PC generation saw the rise of the computers, the birth of popular operating systems like MS-DOS and later Windows. Applications included word processing, spreadsheets, early desktop publishing, and computer gaming. Next, the internet and the web generation focused on the development of the World Wide Web and widespread adoption of online services, e-commerce, email, and web-based applications. Mobile and app generation is the latest one and emerged with the proliferation of smartphones and mobile devices in the 2000s. Mobile applications became popular with growth of cloud computing, mobile internet, and the Internet of Things. There can be overlap and ongoing advancement within each of these generations. Now coming to the third, which is the software development practices, let us see how it has evolved. In the context of software development, there is no universal accepted categorization of generations as such, like in the hardware architecture. However, there are commonly used terms that describe different eras or approaches in software development. Procedural programming, often considered as the earliest approach to software development, involves writing programs as a series of instructions that are executed sequentially. This approach was dominant in the early days of programming with languages like Fortran and COBOL. Structured programming emerged as a response to the complexities of large-scale software development. It promotes the use of structured control flow constructs such as loops, conditionals. It improves the code readability, maintainability, and modularity. Languages like C and Pascal popularized this approach. OOPS, that is Object-Oriented Programming, revolutionized the software development by introducing new concept of objects which encapsulates both data and behavior. The OOP promotes principles like inheritance, polymorphism, encapsulation, enabling modular and reusable code. Languages like C++, Java, and Python are commonly used languages which use the OOPS. Component-based development focuses on creating software systems by assembling reusable software components, which are self-contained and independent modules can be integrated into larger systems. This approach enhances code reusability, maintainability, and scalability. Technologies like COM, DECOM, Java Beans, and .NET support component-based development. Service-oriented architecture (SOA) emphasizes the use of loosely coupled services that communicate with each other over a network. Services encapsulate specific functionalities and can be combined to create complex applications. This approach promotes interoperability, scalability, and flexibility. Web services and frameworks like SOAP and REST enable the implementation of the service-oriented architecture. Now coming to the Agile and DevOps. They represent a shift in software development methodologies towards iterative, collaborative, and customer-centric approaches. The agile methodologies such as Scrum and Kanban focus on iterative development, frequent feedback, and adaptability. DevOps emphasizes close collaboration between development and operations teams to automate processes and improve software delivery and the deployment. It's worth noting that these generations are not definitive or exhaustive, and software development practices continue to evolve with emerging technologies and methodologies. The boundaries between these approaches can also be blurred as many modern software projects combine multiple methodologies and paradigms based on their specific requirements. Information processing, starting with manual processing, it's a slow and limited process, heavily reliant on the memory and the physical tools, and it is from the storytelling, drawings, and simple calculations. Coming to the next, from 17th to 19th century, mechanical computation, the development of mechanical devices like abacus, slide rule, they marked a significant leap in the information processing and facilitated basic calculations. Coming to the electromechanical era, the invention of the telegraph systems and the telephone laid the foundation. Switches and relays were used in the early computers for basic data manipulation. The introduction of microcomputers and development of the graphic user interfaces brought computing to the masses, gave birth to the companies like Apple and Microsoft. In 21st century, it witnessed a digital explosion with advancements in digital storage, processing power, and connectivity. Cloud computing, big data, proliferation of smartphones accelerated the evolution of information processing. And the current era is marked by the artificial intelligence, machine learning, quantum computing, cutting-edge technologies that are redefining the limits of information processing and promise to solve complex problems, analyze vast datasets, and create new frontiers. This evolution of information processing is very closely related to the various phases of industrial and technological revolution and for improved efficiency, enhanced communication. So the first revolution characterized by mechanization of the production through innovations, spinning, steam engines, Jacquard loom. Second industrial revolution saw the proliferation of computers and integrated circuits, microprocessors, early networking, automation, and the data processing became central for manufacturing and other industries. Now coming to the fourth industrial revolution, which is the present and beyond, is often referred as Industry 4.0, is characterized by fusion of physical, digital, biological technologies. The advancements in AI, IoT, cloud computing, big data analytics are revolutioning industries by enabling real-time data processing, predictive maintenance, and automation. The evolution of web. There's Web 1.0, Web 2.0, Web 3.0, and Web 4.0. So in Web 1.0, it's a static websites with limited interactivity. The users consume the content, mainly it is text based. So early search engines emerged using this HTML and HTTP protocol. The static pages had limited interactivity, and the limited CSS and the JavaScript was used for basic styling and minimal scripting. Coming to Web 2.0, the shift was there towards the user generated content and interactivity. Social media platforms, Facebook, Twitter gained prominence. Blogs, wikis, forums allowed user contribution. The AJAX, that is asynchronous JavaScript and XML, allowed dynamic updates without reloading the entire pages. Then rich user interfaces, the REST APIs, representational state transfer, enable data exchange between the servers and clients. CSS3 and advanced JavaScript improved the styling and richer functionality. Web 3.0 is also known as semantic web. It focuses on the structured data and metadata for smarter content, and it's the concept of linked data emerged through web ontology, language, OWL, then the SparkQL protocol, RDF query languages, allowing complex relationships and hierarchies between the resources. So the structured data embedding metadata was there to make the content machine readable. Web 4.0 is the latest one, emerging trends, current and upcoming advancements, emphasis on decentralization, blockchain, AI and immersive technologies. This is a more user-controlled, interconnected web experience. This has more personalization, recommendation, the automation using the AI, and it also uses immersive technologies, supports immersive technologies like virtual reality, augmented reality for interactive experiences. Then WebAssembly was the high-performance binary format for running code in browsers. And decentralized web, exploring technologies to give users more control. Coming to the evolution of the software development architecture, there are this monolithic, layered, client-server, service-oriented, microservices, and full-stack architecture. So each of these architecture is having its own strengths and weaknesses, and the choice depends on many factors like project size, complexity, scalability, team expertise, and more. So in the monolithic architecture, it is built in a single unit, tightly interconnected, simple to develop for small projects. It's difficult to scale. In the layered architecture, it's having application layer, business logic layer, data access layers, and the separation is there, easier maintenance, scalability is there. Challenge is it's a tightly coupled layers. The client service architecture, this layered part is divided into the client user and the server. The server is having this logic and the data, and the client is mainly for the user interface. The advantages is clear separation between the client server responsibilities, but there is a communication overhead every time the client and the server is communicating. Service-oriented architecture, it's composed of loosely coupled reusable services that communicate via standardized protocols. So the reusability, interoperability, flexibility are the advantages. The problem is here managing, coordinating multiple services is a bit complex. Microservices architecture, the application is divided into small independent services where each of them is responsible for business functionality. The services that communicate through the application program interfaces, the APIs, the scalable and independently it can be deployed, so it's having easier maintenance and updates. The challenges is managing and monitoring numerous services, and there can be some network latency. Coming to the full stack architecture, the developers work on both the front end and the back end of an application. So it's an end-to-end aspects of the application, better understanding of the entire technology stack. The challenges is requires proficiency in wide range of technologies. Technology trends can change rapidly and new innovations can emerge. It's always best to refer to some official reports like Gartner's for the most accurate and up-to-date information on emerging technologies. Some of the emerging technologies listed are artificial intelligence, virtual reality, quantum computing, blockchain. If you see in this report, the edge computing, 5G technology, quantum, blockchain and distributed ledger technology, augmented reality, virtual reality, metaverse, biotechnology and bioinformatics, cybersecurity technologies, autonomous vehicles, smart transportation, sustainable technologies have been focused.